Welcome back to part 2 of the gold-filled scrap refining video. In part 1, we recovered the foils, and now what we're going to do is refine these foils into pure gold. Start this off by transferring the material into a tall 2-liter beaker and getting a weight on the material. The recovered gold foils weigh 77.1 grams. We'll write that right on the side of the beaker. I add hydrochloric acid to the beaker up to about the 375 milliliter level. Next, I cover the beaker up and put it up on the heating pad and start adding some heat. Chances are high that we're going to have some lead in this gold-filled scrap, so I'm adding 1 milliliter of concentrated sulfuric acid to precipitate out any lead as lead sulfate. Based on previous experience with this kind of material, I'm just going to measure out 40 milliliters of concentrated nitric acid and add it right on in. I've got a nice big beaker, so that if we get a runaway reaction, it should not overflow that large beaker. After I add the nitric, the aqua regia immediately begins dissolving the gold foils. The gold foils being as thin as they are, we should not have to worry about passivation, but we'll probably end up with some silver chloride in there. This is about 30 minutes worth of footage, speeded up with time lapse, and you'll notice that we get some pretty dark fumes being produced. I turned the heat up halfway through here, right there. You can see we get a little bit more vigorous reaction, and then the fumes start to dissipate. I'm adding about 70 milliliters of hydrochloric acid here, just to make sure that the reaction didn't stall. I'm adding another dose of concentrated nitric acid here, about 2 milliliters. Just to see what kind of reaction we get, so that we can gauge how far along we are on getting all the gold foils dissolved. Judging by this very docile reaction, it looks like we may have everything in solution now. I'll leave it on the heat for a little while. We'll take it down, look at it. I've got a rolling boil going in there, and there's no fumes being produced, so it's a pretty safe bet that everything has dissolved. Now we're going to take it down off the heat and let it cool off. This is time lapse, about 20 minutes or maybe 30 minutes worth of footage here, just letting the solid settle out and the liquid cool. Now what we'll do is filter the solution. I'm making a couple of errors right here. The flask that I've selected is too small. It's a 500 milliliter flask. I should have used a 1 liter flask. And if you notice, the filter paper is folded up the sides of the funnel there. That's not necessary in this case when I'm filtering out solids that are unwanted. And here's an important test to make sure that I have gold in solution. Testing the solution with stannous chloride. As I was pouring the liquid into the filter, I noticed I had some undissolved solids down at the bottom of the beaker there. Looks like it might be some undissolved pieces of gold. We'll get that out of there and examine it closely and see what that is. Here's where my error becomes apparent. That flask is full. I've run out of room, so now I gotta transfer the funnel to a new flask so that I can keep filtering our solution. Those pieces in the bottom of the beaker look like they might be gold. I'm not going to go after them. I'm just going to proceed with the refining and precipitate the gold out of the solution that we already have filtered. Here's a look at the stuff that was down in the bottom of the beaker that didn't dissolve. This might be carat gold. There might be some undissolved pieces of gold filled material here yet. Doesn't look like it, but it might still be some gold foils that didn't quite dissolve. Here's a stone, it's probably a CZ. Here's a little ruby. Here's a piece of material, it looks like steel. But I'm not going to go after this stuff. What we'll do is we'll save it up and put it in with my next batch of carat gold. Here I'm using distilled water to try to rinse all the gold out of the filter paper. I'm not going to be able to get it all out of there, and this will affect our yield slightly, reducing it because some of the gold is going to get carried over out of the process in that filter paper. Got everything pulled through this filter now. Here's what's left in there. And what I'll do is I'll put this filter in my paper storage. But for now, what I'm going to do is use a separate flask now and filter both of these solutions a second time through a brand new piece of filter paper here. Let me get this thing wetted. Now, this should pull through very quickly because it's already been filtered, so shouldn't be any solids in this liquid that I'm pouring in right now. It should go through the filter very quickly. Yeah, that took less than 30 seconds to pull through that filter. That one's done. Now this is the one I'm worried about though. This has got some solids that have settled out on the bottom here. And so what I want to do is I want to try to get most of these solids filtered out of this dark green liquid in our first flask here. Alright, if you notice the bottom here, down at the bottom of this flask, it's just a little bit of solid material that settled out, and I'm trying to get all of that filtered out before we do our precipitation. If you look down here, you'll see our solution has turned cloudy, and that's what I'm talking about. Look at the bottom of that flask right there. That's probably silver chloride. I'm going to try to filter most of that out. Here you can see that the filter is loaded up now. I can see the liquid coming through the bottom of the funnel is cleared up, and our filter is loaded up, but our solution down here is still cloudy. So what I'm going to try to do is filter it through the same filter a second time. Alright, let's put a new flask on here. Transfer the filter to a new flask, and now we're going to pour the solution that's cloudy. See how cloudy that is? Try to get it cleared up now that this filter is loaded up. Pour it back through the same filter a second time. Here you can clearly see the difference that it makes passing that liquid through the filter a second time. It's much clearer, much cleaner. Okay, this is looking much better now. I'm glad I did this second filtering to get all that silver chloride out of that solution. Okay, here we go. We've got all of the solution pulled through that filter a second time. You can see there's lots of solids built up in the filter. I'm not going to rinse the filter down into my good clean solution down here. Instead, what I'll do is I'll just transfer the funnel and the filter over here to this other flask that's still got solids down in the bottom of it. Rinse it all out and then add it to this temporary container back here and precipitate it out later. But I don't want to pull any of the stuff that we just filtered out in here down into this good clean liquid here. Now we're going to transfer our good clean gold solution to a good clean beaker. Notice how clear that liquid is after we passed it through that filter. That's just fantastic. Well worth the time to do that. Get that contamination out of there while we have the opportunity to do so. Here we go. Here's the fun part. We're going to use some sodium metabisulfite to precipitate the pure gold out of this green solution now. Here we go. I'm going to add a spoon of stump out to our gold solution, and we're going to precipitate the gold for the first time here. Get it out of that green liquid. It never ceases to amaze me. I never get tired of watching this happen. We're adding a chemical to that solution that contains gold, and the gold is coming out of solution as a brown powder that settles to the bottom of the beaker. It's just absolutely fascinating. I never get tired of watching it. Can't really see it that well because the solution is so dark, but we've got the gold precipitated now. It's down here as a brown powder. The gold is settled now, and I need to get this waste out of here off the gold so we can get the gold. And if you look over here, this is my temporary waste container. It's full. So what I'm going to do, I just emptied out my stock pot. This is my stock pot where every drop of gold refining waste is funneled through. I keep pieces of copper in here so that any of the waste that I pour in will cement out any traces of precious metals that are in this waste solution that I'm pouring off. A little bit of gold will go off in here. If you look down here, we got a little gold being poured off, but I just need to make some room in this temporary flask so that we can get the waste out of our gold filled batch here. I set this outside and run an air bubbler through it, and then once the reaction is complete and there's no more precious metals in this solution, I siphon it off into a waste treatment bucket down here that's full of iron. And in this bucket, the copper that comes out of the waste treatment, or the stock pot, the copper solution that comes out of here goes down into this waste treatment bucket that's full of iron, and the copper cements out on the iron. This bucket is half full of copper right now, and the copper is useless to me, and I end up, after I get all the solution out of there, I end up just throwing it away. This is another temporary waste container for my gold refining waste. You can see down at the bottom down here I've got some gold that settles out, and what I do is, since my stock pot is so small, I just accumulate this waste, and then I add it to the stock pot whenever I empty it out. And by storing the waste in these temporary containers, I can get the gold out of them, because the gold will settle out down here on the bottom, and I can just pour the solution off and then recover the gold. I almost forgot I had this little bit of waste from the from something earlier. Need to add that into the stock pot. All right, now we can cover this up, take it out and set it underneath one of my totes to keep the rain off it and bubble some air through it. Keep a cover on the waste treatment bucket. It's got a hole in it. I put an air bubbler through here, and I keep it outdoors. Keep both these outdoors because they do produce some fumes. Now that I've got some room in my temporary waste container, I'm going to pull down our gold here, and we're going to pour off the waste into this temporary container. And again, the reason I do this in a temporary container is because some of the gold usually gets poured over with the waste. And as you can see in there, in this container here, there's already a little bit of gold in there. But by doing it this way, I can let it settle. Then I can pour off the settled liquid here that may contain some platinum group metals. Leave the gold down at the bottom of the container and recover the gold separately and get it out of the waste container. Here's a look at our gold here. Looking pretty good. Nice. It's our gold mud. I'm going to do several small rinses with hydrochloric acid here. Try to get all the chemicals rinsed off before we proceed. And this just gets poured off right into the temporary waste container. I rinse the gold off over and over with hydrochloric acid and a little distilled water to get all of that green liquid rinsed off of the brown powdered gold. Notice that I'm using very small amounts of hydrochloric acid to do these rinses. Alright, this is about the 12th rinse or so. What I'm looking for here is for all the color to be rinsed free from the gold, and still got a little tint of yellow. What we're trying to do is get all the non-gold metals that are in solution, that stayed in solution when we precipitated the gold. We're trying to get those metals rinsed out with these hydrochloric acid rinses. I'm going to rinse with just water, distilled water, to rinse the acid off of the gold now. Alright, that's distilled water on there. I've got all the acid rinsed off of here now. So what we'll do, I'm going to pour off this final distilled water rinse. And we're going to add some hydrochloric acid to our gold now. About 100 milliliters or so. As per usual, I'm going to add a little bit of sulfuric acid here, just in case there's any lead in there. It'll precipitate out as lead sulfate and we can filter it out. I'm going to add some concentrated nitric acid now. We're going to put about 4 shots, 3 ml each, in here. And now what we'll do, we'll cover this up and stick it up here on the heat. Let it dissolve. Okay, here we go. We've got a little bit of a mishap here. I turned the heat up on extreme high on the burner and then walked in to do some editing. Forgot that I had done that. I should have turned it back down. But as the gold dissolved and the nitric got used up, you'll see the fumes start to clear up here, and then it boils hard, and then it starts popping steam bubbles in there and ejected some of the gold out of the beaker. I could have edited all of this out of the video, but I figured I'd leave it in to show you what happens when we aren't paying attention. And then what I do to clean it up here, I'm just taking a piece of wet filter paper and wiping the gold off onto the filter paper. And then what I do is I just throw the filter paper with the gold on it in my little gold collection container back there in the back, and I'll be able to recover that later on. Here I'm going to add some hydrochloric acid and more nitric acid to continue this reaction. There's still some gold powder down at the bottom of the beaker, and I believe that's why we had those steam bubbles form. The powdered gold that laid down on the bottom of the beaker caused some hot spots and then caused those little steam explosions and ejected the gold out of the beaker. I just added about 2 ml of nitric acid, and you can see the solution's clearing up right before your eyes down there. Now we're going to set it back up on the heat and continue to dissolve the rest of the gold powder for this second refining. Here's what the reaction should look like. Nice and stable, controlled reaction, instead of the violently boiling reaction that ejected the gold out of the beaker. A few minutes later, all the gold is dissolved. I'll take it down off the heat. I don't think we lost a whole bunch of gold in that mishap. I wanted to leave it in to show what can happen when we don't pay attention. I've allowed the solution to cool completely. Ambient temperature today is about 50 degrees Fahrenheit. So now what we're going to do is filter our solution. Notice how cloudy, notice how clear it is. After this second refining, there shouldn't be a whole lot of solids to have to filter out here. Well, the solution did turn a little cloudy there. So what we're going to do is pour it back through the same filter a second time. See how cloudy that is? Try to get some of that out of there by going back through the same filter a second time. If you look at the filter, you'll see that we've got some contamination around those filter holes where the fluid pulled through the holes in the bottom of the funnel there. So there definitely was some contamination. We've got it all out of there now, I think. Our solution down here is clear and bright. I'm not going to rinse the funnel down into our filtered solution. What I'll do is I'll put this funnel on this flask and then rinse it out into here and then add this liquid that may have a little bit of contamination back here into my gold storage container for later recovery. For this precipitation, I'm going to use a different precipitant. I'm going to use some ferrous sulfate. Got a stir bar here. I'm going to add some distilled water to this. Turn on the stir bar, add some heat, and I've got about maybe an ounce of gold I'm expecting out of this solution. So what I'm going to do is add, this is iron sulfate, formerly known as high yield copperas. It is ferrous sulfate, and ferrous sulfate, according to Hoke's book, will bring down the gold, all the gold, and nothing but the gold. So I'm expecting an ounce of gold here. I'm going to add about 2 ounces of ferrous sulfate to this beaker. I've got the copperas to dissolve. It's brown. So now what we're going to do is we're going to add some hydrochloric acid to turn it green. There we go. All right, let's get set up to do this precipitation. The reason I'm using a different precipitant for this second refining is because this is a repurification, and when we do a repurification, we want to use a different precipitant. Here's our filter rig. This is just a plastic lid that I've cut a hole in to support my funnel. This is a piece of filter paper in here. We'll wet this. Filtering the ferrous sulfate solution into our gold solution now to precipitate out our pure gold. Here we go.
Using ferrous sulfate takes a little longer to set it all up, but if you notice down at the bottom of the beaker, you'll see some tan colored material. That's our gold, and it's very high purity.
Let's do a quick Stannis test here to make sure that we've got all of our gold precipitated out of this solution. Just going to dip a little piece of filter paper in here, get a little of the solution on the filter paper, hit it with Stannis. As you can see, we still got a ton of gold in there that's got to be precipitated.
That's my lack of experience with ferrous sulfate. Add some more water to the beaker, turn on the stir bar. I'm going to put in some more copperas and dissolve that. Add a little bit more hydrochloric to turn it from brown to green. And then we'll start adding the dissolved ferrous sulfate through that filter to try to precipitate out the rest of the pure gold from our solution. This is pretty cool. If you look to where the droplets of ferrous sulfate solution are hitting the chloruric acid solution. You can see the different densities between the two liquids, and you can see the gold coming out of solution ever so slightly there as those drips hit the solution. This is about an hour time lapsed into a few seconds. You can see the gold building up down on the bottom of the beaker. Here I do another quick stannous test to verify that all the gold has precipitated out of that solution. As you can see, negative test means all the gold has dropped. Now we're going to pour off the waste into my temporary waste container. As I pointed out earlier, some of the gold gets poured over as I pour this waste into that flask, but that's okay. It'll settle to the bottom of the flask, and I can recover the gold that settles out later on. Here's a look at our pure gold mud. I ran out of room, so I got to use a big beaker here to collect my waste. I'll start the hydrochloric acid rinses to get all that iron rinsed off our gold powder. Rinse the sides down with some distilled water. Then I pour it off into the waste container. I'll do this over and over until I've got all that iron rinsed off our gold powder. I'm rinsing all the acid off now with distilled water, and the gold powder is in a very finely divided state. Notice how I have to set the beaker sideways to get it to settle a little bit before I pour that rinse water off. That waste solution looks just like gold in solution. Many a novice refiner has been fooled into thinking that there's gold present when there's not. I'm pouring off this last distilled water rinse, and then what we'll do is add about 200 milliliters of hydrochloric acid in preparation for a third refining. There shouldn't be any lead in this gold, but I always add sulfuric acid whether I suspect the presence of lead or not. Now I'm adding about 20 milliliters of concentrated nitric acid to the gold to dissolve it a third time. Cover it up, put it up on the heat, let it dissolve. Didn't take long to get it all to go back into solution. I was expecting a nice, clean, clear solution, but if you look, it's still cloudy. There's something still in there. All right, I'm having a problem. I've got some stuff following the gold. Still got some cloudy, some kind of precipitate in here. Try to filter it out one more time right quick. I cannot seem to get this to clear up. I poured it through the same filter about 4 or 5 times. Still cloudy, so I give up. What we're going to do, this is not uncommon for gold-filled stuff. It's got something in the gold-filled material that's following it through the entire refining process. I'm going to do the third precipitation now with some sodium metabisulfite, stump out. I'm just going to throw the towel in on trying to get high purity here. I'm just going to get the gold out now and melt it up into a little bar and be done with it. That should do it. Do our hydrochloric rinses now. I'm going to pour this off into a waste container, and we'll rinse the chemicals off the gold just like before.
See if we can do this in one take. Get the gold down into our melt dish here carefully. Zip, just like that. A few crumbs on the edge there, I'll get those out later. Let's go ahead and put this over on the melt table. Fire this up and start the melt.
Well, it was highly disappointing not to be able to get the gold refined to a very high purity, but I think you'll see here in a minute when we get the yield on this that it was well worth the effort. I wanted to get it up real high purity so I could stamp it up and try to sell this bar, but what I'll end up doing is probably repurifying it at a later date, or I'll just end up keeping it, which is no problem. Either way, I'll probably do a repurification on it to get it to high purity.
That bar don't look too bad. Bar of pure gold from gold-filled scrap. Not bad. Not bad at all. Okay, here's our bar. Looks pretty doggone good. I would be hesitant to call it high purity though because of the cloudiness that was in that solution. Now let's see what we got for weight here. Whoa, 45.6 grams of pure gold from 1,412 grams of gold filled scrap. Wow, very nice. All right, that was much more than I was expecting. 45.6 grams divided by 1412 equals, that's 3.2% yield, and I got 45 grams of pure gold here. Very nice. I'm kind of glad this was over. It presented some problems. It created some problems for me, but we got the pure gold. Thanks for watching.